Okay, so I'm going to start by looking at creating the detailed drawing for the clamp block. Okay, so the clamp block here, and I picked this one because it doesn't have a ton of dimensions on it, but we do see both rectangular coordinate dimensioning, notes, and GD&T on here. So I think it's a great place where we can get a sampling of a little bit of everything. So what I'm going to do is I'm going to pull up the clamp block. Why would you use GD&T on it?
What was that?
The square dimension? Oh, I'll talk about that in just a little bit. Yeah. So the question was, how come there's a square around this dimension, right? Rather than just regular. And I'll tell you about that in just a little bit. So let's go ahead and I'm going to start the process of, I'm going to close out what I have here, close out this, and I'm going to open up my model for the clamp block. So clamp block model open. Okay, so here is my clamp block. Now I'm going to rename this because I'm going to create a new drawing for it and start the whole process over. So you don't have to rename yours, but I'm going to call mine clamp block 1. Okay, so my clamp block I created with the counter bores, and I've got the thread through here. And it's a what we call a cosmetic thread. So it didn't cut the threads, just like what we did and we showed in the demo. So as we look here, we want to create the drawing. So I'm going to go up to the top here, new, and I want to make a drawing from this part. So I'm going to click that. And I'm just going to do my drawing and see, okay. And I'm going to browse for a B-size border. So wherever you saved your B-size border is where you want to go. And open. And okay. So my B-size border comes in. And now I'm going to, now again, remember the drawing guides are out there. My expectation is that you're using these drawing guides and you're going to duplicate what we see here. So we want to add a front view, a top view, and then an isometric. So I'm going to go over back to SolidWorks here. So I have my front view. Okay. And I'm going to hit OK. Now, because it was a cosmetic thread, it automatically brings this in, but this is not the standard call out for the whole. So we are simply going to left click on that and delete it. Do not use that. All right. We're going to be putting it in the way it should go in. Then what we're going to do is we're going to create another drawing view that's projected from that. So I'm going to project off of this view straight up to the front view. And then I'm going to do another projected view from that front view. And I'm going to do an isometric up and to the right. I'm going to move that over. I'm going to change it to that one. And then I'm also going to change it to a custom size and make it a little smaller. So 1.5, so it doesn't take up too much room. Kind of position it up here. You'll notice that it did add the center lines. I don't really care for them in my isometric, but if you leave them in yours, it's fine. It's fine. They're not terrible. But I like them in over here. Now, make sure that your views over here have the hidden lines and center lines, okay? If they don't, you just click on the view and you are going to go to display style and you want to be on the second one here, hidden lines visible. Okay? And then I'm not going to spend time filling in the title block, but you're going to want to fill the title block and make sure you use the part number that's right here. Okay. Now we're going to start adding our dimensions. I always like to add all of my rectangular coordinate dimensions before I worry about the GD&T. So I'm going to put in my dimensions just like we're used to. So for instance, there's an overall height of 2.5. I'm going to go to annotation, smart dimension. And again, this is very similar to the dimensioning that we do when we sketch. So there's my first dimension. I'm gonna add my overall dimension up here. I've got 1.5 out here. I have a dimension from the bottom to the center of that hole, 0.75. I've got from hole to hole, 2.25. Now, the other thing that you'll notice here, these are all 3-place decimals. If you don't have 3-place decimals set up in your template, okay? But most of these are, you can just, I'm gonna hit okay here. You can go up to options, document properties, go to your dimensions tab, and your primary precision is gonna be 3-place decimal, okay? Again, as I look at this, almost all the dimensions are 3-place decimals, so I want to add that in. So 3-place decimal there. I'm going to go down here, smart dimension from the bottom to the center, 1.5. And I think I have all of my linear dimensions in place, okay? The next thing I'm going to do is I'm going to add my counterbore call out. So that is going to be smart dimension. I'm going to click on my smaller diameter and I'm going to just pull it out over to the side here. Now, the diameter that I clicked on was 0.781. I'm going to extend and add to this note. I am going to go in back of that note and do, right here is the dimension text, and right in back of that, I'm going to do a space through. Okay, that means that that center hole is going through. Then I'm going to hit enter and I'm going to use the counterbore symbol. The counterbore symbol is right down below here. I'm going to click on that and then I'm going to do a space and then I'm going to do the diameter symbol, which is right above. And then I'm going to add 1.188. And then I'm going to do a space. And the depth symbol is this horizontal line with the arrow going down. And then 0.765. So it's what it's saying is we're going through a diameter of 0.781. The counterbore diameter is going to be 1.188. And it's going to go down a depth of 0.765. Now, if you compare it to what I have over here, this one is right justified so that by the landing of our leader, the note starts here. To do that, I'm going to go back over here. You'll notice that right below the dimension text, this is where we can set the justification. Right now it's on center justify. We want it to be in line with where it starts. So it's going to be a right justify here. Okay. And I'm simply going to hit OK. And now that note is in place. All right. The next note that I want to add is going to be for this threaded hole. If I do a smart dimension and I click on that threaded hole, it is going to automatically call out for me the 7A-9 UNC. And all we want to add to that dimensions text is space through. So they know that it goes all the way through the part. Okay. So again, take off the one that says tapped hole on it. That is not a standard call out. Erase that one when it comes in and then redo it as a smart dimension like we just saw here. Now, this would be what we need dimension wise if we didn't have any GD&T on here, but we do. So we want to add the GD&T that is on our print. So let's kind of look at what we have. First of all, you're going to notice that we have a flatness tolerance here. The symbol that we see here is for flatness. Okay. Flatness of 0.005. So when we look at this overall height dimension down to this point right here, this has a standard tolerance added to it. It's a 3-place decimal. So when we look at our title block, if you look way down in here, you're going to notice that for a 3-place decimal, this has a plus or minus 5 thousandths tolerance on it. So right now, this would go up to 2.505 and go down to 2.495, okay? The difference between those two is 10 thousandths, okay? So any dimension on a drawing that does not have a tolerance specifically in back of it has a tolerance that defaults to the title block. And I'm sure as machinists, you guys already know that, right? You always look to the title block for those high and low values. So these are our limits, we call those. Now, if my flatness is okay at 10 thousandths of an inch, because right now the variation between the high and the low values of those two dimensions, the limits, would give me an automatic flatness of 10 thousandths. I don't put flatness on this, okay? I can leave it alone, but by putting flatness on this surface, it tells me I want it better than what that size tolerance is allowing. Okay, I only add GD&T if I need a refinement on this, okay? And we most often put it wherever we have mating surfaces. So when we look at this part and how it's oriented in our assembly, this is the surface that's sitting down on that base plate. We want it more flat than the top. Right? The top, it's no big deal. However, if it's a little rough on the top, it doesn't matter because it's not dictating anything function-wise in our design. But down here, we want this to sit nice and flat so that it has good contact with the base plate underneath, right? So that's why this is flat, and it's a value that's less than what the size allows, okay? So 5 thousandths is the value in here for flatness. Now, underneath, you're going to notice that there is that B. That B is what we call a datum. Once we, I'm going to say, qualify that surface, you maybe have heard that before. We're qualifying that surface so that now it can be used then as a reference for other parts, for other dimensions to be made from. So we make it nice and flat first, we kind of machine it off, and now it can be used in other instances. So we're going to add that flatness tolerance to the bottom of the part. So we're going to go down, we're going to go back to SolidWorks over here. To add GD&T, we're going to be on that annotations tab, but we're going to go towards the middle here. And right here in the middle, there's geometric tolerancing. Okay. I'm going to click on that. And you're going to notice that when you bring your cursor down into the graphics area, you're going to have a square on your cursor. That is the start of what we call the feature control frame. Okay, that's that box that's created. So all you're going to do, don't worry about being on here. Just left click off of the surface, and when you left click, it's going to have a series of symbols there, and the symbol that we want is going to be flatness, which is right here. So I'm going to click on flatness. It's going to put in there. And then it's going to ask us how much we want that to be. And we're going to put in here 0.005. Now, I'm going to tell you, do not put 0.005. In the English system for dimensioning, we do not put a leading zero on things that are decimals, okay? In the metric system, you do. But in the English system, we do not lead with a zero for anything that is a decimal. So start with 0.005, okay? And then if we look at our feature control frame, that's all that we need there, all right? So as we're just doing the feature control frame here, I'm gonna go back to SolidWorks, and I'm simply going to move this up and hit done, all right? I'm gonna unselect, I can either hit the green check mark or escape, and now I have my feature control frame for flatness, okay? I'm going to grab this. I'm going to left click on it. So make sure you don't have that dialog box open. I'm going to left click it, and I'm going to remember how to do this. I'm going to activate that dimension so it's down on the bottom here. So when it's in that orange state. And when you release, it should jump to the bottom of that dimension. Did that do that for you guys? Okay, so you have to drag over the top, kind of activate that dimension, and then release, and it'll grab to that. Now, if I move this, it stays in line, and I do want this to be just beyond that dimension, so it's not underneath the arrowhead. And then I can left click or accept that, and it's in place. So if I move this view around, it goes along with it. Okay, that's what I want to happen. So don't eyeball it and just get it close. Make sure that it's attached to that dimension. Takes a little bit of playing around, but if you get that dimension activated, it's good. Now I'm going to add the datum underneath there. Okay. So we're going to go up to annotation again, but right underneath the geometric tolerance is datum feature. That's what we want to add this B with. I'm going to click on datum feature and I want to change my label setting from A to B, capital B. All text is going to be capital. And then what I'm going to do is I'm going to just go close to my feature control frame, click, and then you're just going to move down a little bit and click again to place it. You're going to have an extra one on the end here. Just hit escape to stop. Okay. So that's that. The next thing you're going to notice in this view is that my 1.5 has a box around it. That's called a basic dimension. We use basic dimensions whenever we are using what we call the position geometric tolerance. That's for locating features of size. This is a feature of size. We're locating that threaded hole, and any locational dimension, it says, don't look to the title block. That's what that box around, it's called a basic dimension. Don't look down here for the tolerance. Instead, we're looking to the feature control frame that's associated with that feature. Okay. So this will not have a plus or minus 5 thousandths in this direction. It actually has a diameter of 14 thousandths centered on 1.5 inch diameter and the midpoint of this feature. Okay. So what we're going to do now is we're going to add this feature control frame similar to the flatness, but we've got a couple more things to add into it. So we're gonna go over here. Before we do that feature control frame, to make something a basic dimension, put a box around it. We're gonna click on the 1.5 here that we want to put basic. We want to put the box around it. Do not put the oval around it. Do not put, it says an inspection. That's what it's called, an inspection dimension. Do not use that one. You are going to go up here underneath tolerance precision. Under tolerance, you're going to arrow down, and the very first one is called basic. You're going to put a box around it, basic. Okay. Do not do the oval. Okay. Because some people are like, oh, I can't, where is the basic? I don't see it. It's under that tolerance. You got to arrow down and it's basic right there. So any of the dimensions that need a box around them, or you see a box around it, you need to arrow down and do basic. Now over here, we're going to do our feature control frame for the position. So we're going to go up to geometric tolerance. That's going to be our feature control frame. We're going to go down underneath, okay, away from it. You don't add the arrow. If you get close to something, it's going to want to add that arrow. We're going to do a position tolerance here. And our value is a diameter. So we need to put a diameter in front. Don't do the S diameter, that's spherical. We just want a regular diameter out in front. And up here, we want to clear that leading 0. We don't want the leading 0. Okay. And we're going to do 0.014. Delete. There we go. Now, we're not done because we need more. So the next thing we're going to do is we need to add a material modifier. That's what the M with a circle around it. It's called the maximum material modifier. So we're going to click on material modifier. We're going to add an M, and it fills it in for us. Then the last things that we need to do are add our datums. So our first datum is going to be the first one in the first spot. That's called the primary datum. That's going to be datum C. And you want to add a new one. Then it goes to the next spot. That's going to be datum B. Oops. I want A at the end. I want to double click. Did it do the B? Oh, I got out of there. Okay. I think I did the B. And then you want to add one more. And then you're going to go to A. And then when you're done, you click done. If you need to add like I did, all you have to do is double click the box there where you need to change it, and you can change the letter that way. Or if you need to add, you can add a text box or a datum as needed. Or if you want to start over, you can do that too. All right. Now, our feature control frame, again, is kind of floating out here by itself. If I move my view around right now, see, if I move my view, it will not move with my view like these guys do. So what I need to do is take my feature control frame and just go over the top of that, that note or that leader. And now it attaches it once I release it. And now when I move my view, it's going to go with it. Okay. So drag it over the top and then release to associate it with that note. The next thing we're going to do, I think if we look back over here, that takes care of this front view right here. Now we're going to go up to the top and do some very similar things. I'm going to change my 2.25 to a basic, my 0.75 to a basic. Oops. Oh, look, I didn't want to do that. SolidWorks is what I want. Okay, so I'm going to change this dimension, 2.25. I simply left click it, I down arrow, basic, and then okay. And it always wants to kind of move it. You might have to move it back. 0.75, down arrow, basic. Okay, move them out. I like them further away. That takes care of the basic dimensions. Then I want to go over here. I want to add the position tolerance. So I'm going to go up to geometric tolerancing, float it first, position. This is going to be 0.014. Add the diameter in front. You need a material, no material condition modifier. So nothing for this one. So there's no M with a circle, which is fine. And then we're going to add our datums. So add datum. The first one is B in the primary spot. Then we add a new one. A is next for that. And then add one more. And C is going to be the last one. And then done. And then we're going to escape out of there. We're going to left click, drag it up onto the note, and then release. And now it's attached to that dimension. So if I move that view, it moves with it. The next thing I'm going to do is I'm going to add a perpendicularity tolerance for this face to be perpendicular within 5 thousandths to, and then it becomes, or to datum B, and then it becomes datum C. So if we go back over here, we're going to add that perpendicularity on that surface. So we're going to do a GD&T or geometric tolerance. We're just going to kind of float it out here. Perpendicularity, 0.005. No diameter because this is not a circular feature. No material modifier. But then we're going to add a datum and it's going to be datum B. Okay, and done. Then we're going to drag it over to that dimension. Release, and it's going to attach to that, that dimension. Now, what does being perpendicular to B mean? So if you remember, we made datum B the bottom of our part. That means that this face right here, which is this face right here, needs to be perpendicular to the bottom of the part within 5 thousandths. Okay, it's squaring it up. It's squaring that piece up is what that's doing. Okay. Now, once that surface is nice and perpendicular, it's going to become a datum. And we'll go to datum feature up on the top here. We're going to click on that feature control frame and then just pull down a distance and put C in place. And then if you would need to, you could change the letter over here. But that looks good. All right. And then we have one more to do. We need to place datum A. Datum A is going to be the width of the part. So we're going to place datum A and we're going to put it, we're going to like select this dimension here and make sure it's in line, okay, with that dimension. And then we're going to left click and we're going to change this from D to, oopsie, double click it, sorry. And then we're going to change it to the letter A. Make sure it's capital letter. Okay. Now, if you put this datum on and you just hit the side here, it's not going to take it. You have to put it in line. Okay. All right. Now, little bit of an explanation here. You'll notice that the datums that we used for positioning, these are going to be where the locations for these have to come from. So for instance, the primary datum for positioning this threaded hole, the primary datum is C. So you're going to notice that C is this surface right here. That sets what we call the orientation. The center line for that threaded hole needs to be perpendicular to this surface right here, datum B. That's like they call it the primary datum. The secondary datum is datum B. That means it's being located from the bottom, 1.5 up, but it does not have a tolerance associated with the title block. We look to our feature control frame for the diameter of 14,000 centered right there. And then datum A is the tertiary datum. If we look, datum A is the width of the part. That means that based on the width of the part, wherever the center plane is for that dimension, 2 inches in, that is where this is going to be located. It's going to be right in the middle of the part. So if that part gets a little wider or a little narrower, it's going to always be the center of whatever that dimension is. So kind of a little bit of an overview of GD&T, but mostly placing it using the dimensioning tools here in SolidWorks. Okay. Now to finish up this drawing, you would fill in the title block completely, but here are all the dimensions for this clamp block. As we glance at it, are there any questions? Does anybody have any questions? I'm going to check the chat box as well. So even with this kind of simple part, we've hit on a lot of different areas that you should be able to do much of the dimensioning that you're going to see on the others as well. But this is just our start. We'll do a couple more drawings as well as we move through this assignment. Okay. Oh, this is going to be a PDF because this is a drawing. So when you hand this in, this is going to be a file save as. Good question. And we're going to send that to, where's my PDF? My PDF right here. So then you'll save it as a PDF and you'll upload. Any drawing will always be a PDF. Any modeling will be the screen snips. Okay. Any other questions? Good. Okay. All right. So that is an introduction to some of the dimensioning.